Hello! Congratulations on your new Xvivo system, and welcome to the Biospherics family. My name is Alicia Henn. I am Chief Scientific Officer of Biospherics, and my team and I are about to take you through some basic training to boost you up the learning curve because we want you to be wildly successful right off the bat with your process in the Xvivo system. Today we're going to be going through Unit 1, talking about the different types of modules that go into the Xvivo system and how they all work together to protect your process. But first, we're going to talk about what makes working in the Xvivo system fundamentally different from anything that you've done before. Now, the Xvivo system was designed with what we call the cytocentric approach to cell processing. What is cytocentric? Well, to describe this, I'm actually going to have you close your eyes for a minute. Now, take a deep breath, relax your neck, shoulders. I don't know where you're listening to this, whether you're in your office or in your living room or in the lab, but I want you to just take a moment. Now, mentally stand in the doorway of your cell culture laboratory. What do you see there? Do you see benches? Do you see chairs? Do you see computers? Now, what of the things that you see in that room actually supports the needs of cells and tissues? Now, open your eyes, come back to me. A lot of people think of this. They think of a traditional room air CO2 incubator. But I'm going to make the case that actually this is a terrible place for cells and tissues. For one, from the cell's point of view, the oxygen inside is far too high for cells that come from inside the body. And the CO2 and temperature are fine as long as the door stays shut. But every time that door is opened, whether it's you accessing your cells or someone else in the lab accessing theirs, all the conditions change. So this is a highly variable environment from the cell's point of view. And if you think about it, even in the pinnacle of cell culture technology, the cleanest clean room you could find anywhere in the world, you have the same source of variability as you find in the rudest, crudest, most basic lab anywhere. In fact, in clean rooms, it's even worse because in clean rooms, people have to wear layers and layers of clothing. So they keep those rooms cold, which makes it worse for the cells when they're exposed to that room air environment. So this is what we call people-centric. It's really designed for the convenience of the people in the lab. Easy access, you can get things in and out of the incubator easily, but it's really not ideal for the cells. Cytocentric incubation is closed. Incubation chambers open only into closed cell processing space like the one you see here. You have constant atmosphere. You can have 37 degrees in that atmosphere. You can have constant HEPA filtration. The gases all come from dry compressed tanks, so there's no room air inside this system. Now, when it comes to cell handling in a traditional room air setting, cells go to something like a BSC. And now it's even worse. The oxygen is too high, the CO2 is too low, and now the cells are cold. So even if you pre-warm your medium, it cools really rapidly in a BSC. And that takes time for it to warm back up after you get the cells back into the incubator. So the cells are actually out of optimum conditions for longer than you actually have them in the BSC. It takes them a long time to come back into optimal conditions. We call these suboptimal transients, and in traditional room air culture, cells are exposed to them all the time. For cytocentric cell handling, you have a closed cell processing space. So you have tanked filtered gases, physiologic oxygen, constant CO2. You have 37 degrees atmosphere. You can have 37-degree floor. The cells are never out of optimum. And because this whole module is at incubator conditions, it's actually like being able to reach your hands into the incubator and do everything you need to do with your cells without the cells ever having to come out here into people-centric room air conditions, which is non-physiologic. Now, it looks kind of like an isolator. the Xvivo system, but it really isn't like it in a lot of other ways. So it has the gloves and sleeves that you work through. It doesn't have that hard glass front that a traditional isolator has that leaves you working like T-Rex in there and bumping your arms on the hard glass. It's different in a lot of other ways too, particularly for the cells. It acts more like a bioreactor in that it has all the right gases in place, it has all the right sensors in place. You can have temperature control constantly. So really the Xvivo system is more like the love child of an isolator and a bioreactor in that you have all the right conditions and it's all isolated from the variability of room air. Now, there's no mixing of the room air with the cell or tissue environment in the Xvivo system. There's no connections to your HVAC system. The atmosphere comes from compressed gas tanks, and gas that is removed from the system can be piped away to a remote location if you'd like. Every module is controlled and monitored independently. You just type in the gas levels that you want in each module. The system will maintain all the settings until you change them. So you can set the cell handling spaces and the incubators for the same conditions or for different conditions if you want them. And all of this control is the biggest difference between a traditional cell culture facility and an Xvivo system for cell culture. Because in a BSC or a traditional isolator or in a RABS unit, you only have filtered room air. You don't have control of any of these parameters. Now, cells really like constant physiologic conditions. We see this time after time after time in all different types of cells. And I have over 3,000 customer publications that we've gathered proving this. But this particular paper is interesting. It's a recent one that's shown that constant physiologic oxygen and temperature really made a big difference for cardiac-derived cells in a production process. And we'd be happy to share this paper with you or any of our other customer publications. Let me know if you're interested in a particular cell model, and I can help provide some of that information for you. Now, the Xvivo system is also unlike anything you've ever worked in before because it provides an environment for cell handling that actively discourages microbes. You have the lower humidity because all the gas comes from tank gases, which are dry. We have higher temperatures than you would find in a room air BSC, and we have the heated floor. All of this temperature and humidity control means that you can control the risk of microbial growth to a much higher degree than you can in anything that has room air. And we have data on this. I can provide, it's right now being published by an industry journal. We're waiting for that to be published. As soon as it comes out, I'd be happy to provide it to you. Maybe by the time you hear this, it's already out. Now, the nice thing about using the actual physical atmospheric conditions for microbial control is that like a gas sterilant, those conditions reach every part of the Xvivo system. It can be monitored remotely. You can have constant automatic recording of those physical conditions. And those conditions are independent of anything like disinfectant wet time and expiration. So it adds a whole new level of microbial control on top of anything that you already have going in your process. So let's talk about the basic anatomy of an Xvivo system. There are 4 basic types of chambers in the Xvivo system. We're going to be going through each one of these. There's the LFH, or the laminar flow hood, which is the entry and exit point for anything being imported or exported from the system. You have buffer chambers, which go between the laminar flow hood and your processing chambers where the action happens. Then you have incubation chambers, which you might have off of that. And then we have equipment chambers, actually, which are specialized type of processing chamber. So let's talk first about the laminar flow hood, or the LFH, and the buffer chambers. Those are what control the conditions around items that are being imported or exported from the system. The laminar flow hood, or LFH, is a space that's designed for staging items as they come into and out of the system. This is a side view schematic of the airflow in the LFH. It's opening out to the room to the right, and the back of the system is to the left. There's a fan in the back that blows room air across the work surface after having been passed through a HEPA filter. This space is not designed for open processing, unlike a room air BSC, although it looks kind of like a BSC. It's really designed to be a safe space to disinfect items and leave them to dry before they come into the system, and to protect the doors of the system from room air so that only HEPA filtered air goes past those doors. There is a mini helic pressure gauge on the front of the LFH, and you should monitor the reading on this every day. We want to watch and see whether it goes up or whether it goes down. It monitors the pressure in between the pre-screen, the blue pre-screen that's on the back of your LFH, and the HEPA filter, which is inside. So if this reading goes down over time, it could mean that the pre-screen in the back is getting occluded with dust from your room. If it goes up over time, it could mean that the HEPA filter is getting occluded. But what if it doesn't do either? What if you have just constant readings? Well, that could mean one of two things. It could mean that both are fine, the pre-screen and the HEPA filter, or it could mean that both are getting occluded equally. So what we want you to do is actually pull that blue pre-screen out of the way and check the reading with and without that pre-screen in place to check the integrity of those filters. The on and off switch and the fan speed control dial you might find on the back of your system right below that blue pre-screen, or it might be on the front of your system like on a processing chamber right next to your LFH. That white dial is the rheostat. There is the fan control, and you turn it, as you turn it to the right, you'll feel a little click. If you leave it set just past that click, then you'll have your fan set at the highest speed, although you can turn it down if you want a lower fan speed. This fan should be turned on and run for 30 minutes before you start your process, and just leave it on continuously while you're doing your process. Now, we have had some customers that didn't realize there was even a button back there to turn it on, and it was on the back of their system, and they pushed the Xvivo system right up against the wall, and they didn't even know it was there. So we want to make sure right off the bat that you know there is a button for the LFH and how to turn it on. It's right there. The laminar flow hood protects the buffer chambers from unfiltered room air coming in. Like I said before, it's a staging area for disinfection. This is not the area for open processing. We want you to do that inside the Xvivo system. Now, the buffer module is the next chamber that you're going to use in your process. After surface disinfection and drying in the laminar flow hood, all your materials go into the buffer module, into a buffer chamber in the buffer module in order to get imported. The one main process that happens in the buffer chambers is called the log dilution ventilation cycle, or just log dilution ventilation. This is where we use an automated process in the Xvivo system to exchange the gases in that chamber with filtered, tanked, medical grade gases. This is data from one chamber of a small dual buffer that was programmed for a single log dilution ventilation cycle. It's a dilution process, so the larger the chamber is, the longer it takes. But in this chamber, it takes between 3 and 5 minutes to complete this cycle. We use oxygen in these chambers as a surrogate for the chamber atmosphere, and so we monitor the oxygen level in order to monitor that gas replacement with fresh gases from the tanks. And it works like this. So the Xvivo system will automatically infuse nitrogen, taking oxygen from a level of 20% down to 2%. And that is a 1 to 10 dilution of the atmosphere in that chamber, or a 1 log reduction. in any particle risk that might be in that atmosphere as well. And you can repeat this for an automated risk reduction. So if you do one cycle, it's a 1 to 10 or 1 log reduction. If you do 2 cycles, it's 1 to 100 or 2 logs. If you do 3 cycles, then it's 1 to 1,000. And the oxygen level is always brought back to the chamber set point when it's done. So if you have your chamber set to 5% oxygen instead of 20%, it would bring it back to 5% at the end of this. Now, buffer chambers do not treat items that you're importing with chemicals the way that some traditional isolators do. Items are disinfected manually in the laminar flow hood before they're brought into the system, and we'll show this as part of the training later on. So this is how the laminar flow hood and the buffer module work together to control airborne risks to your process during import of materials and export. So the next part of the Xvivo system that you come to is the processing chamber. The buffer chamber opens into the processing chamber, and these can be configured in a huge variety of ways. Whether they have incubators on them, whether they have gloves on both sides, whether they're heated, whether they're chilled, whether they have hanging bars in them, whether they have magnetic plates, they can have all sorts of functionality built into them. In the ceiling of the processing chamber are a series of filters and sensors that you see here. These are the input outputs or the IOs for the sensors that the Xvivo system uses to control the space. The continuously recirculating atmosphere cleaning system or crack system operates at all times like a refrigerator. And this is something that you want to leave on at all times. One of the top worries of new users is being able to reach things inside the Xvivo, especially if they've worked in a traditional isolator and they've had trouble reaching things. Here's Dr. Yan He, a small woman on our team, and she can easily reach cells in the incubator in the back. The glove front is soft and a little stretchy, but it's quite tough. So, and this particular glove front has been in continuous use for 7 years. So don't be afraid to push into that glove front and to reach things. It can accommodate that. Go ahead and give it a shot. Don't be shy with glove front. Another huge worry of a lot of new users is working through these thick, clunky gloves that they've had to work with in other isolators. Now, your Xvivo system was shipped with Nitrosolve gloves that are a heavier dishwashing type glove. And many users prefer a thinner surgical glove. And that's okay. You can put those on if you want to use those. But there are pluses and minuses to different glove types, which we'll go through in Unit 6 so that you can make the best choices for what type of gloves you want on there. Now, these gloves can also be changed without compromising the environment in the chamber. And we will show you that technique as well in a later video. The processing chamber and the incubation chamber together make a cytocentric space that is like an incubator. The cells never have to leave. You can do everything you need to do with them inside that space. So let's talk about the incubation chamber a little bit. It, like I said before, opens only into this controlled cell processing space, so cells aren't exposed to the variabilities of room air. Each one is independently controlled and ventilated. Each incubation chamber is in an incubation bank module. So an incubation bank module can have one big incubator like you see on the left here, or it can have 2 separate incubators like you see on the right. We've even done some with 3 separate incubators. It depends on what you need for your process. Now remember, you may need room for a pan in here to provide some humidity. So while you see 9 shelves in the big incubator and 4 shelves in each of the ones on the right, you're going to want to plan for having some water dishes in there as well for humidity. Each one has separate controls, separate ventilation, separate monitoring. They can have different depths. You might notice that we turn these shelves so that the edges are upward. And these cell culture vessels can then be nestled down inside the shelf instead of sitting on top the way that you see in a traditional room air CO2 incubator. It's just more secure for the vessels because we do a lot of sliding the shelves in and out in order to bring those into the processing chamber area as we access things. So this is a deliberate choice. You can have up to 3 different incubator bank modules and 1 processing chamber like this one here, 2 on the back, and you can have 1 on the side too as well if you need that. So let's look at how the heat is controlled to the incubators. This is a top-down view of a processing chamber with 2 incubator bank modules on the back. Now, incubator heat is controlled by the whole incubator bank module that's on the back and sides of the system. That's where the incubator bank module, IBM, is controlling heat. And the processing chamber controls the heat from the front of the incubators. So it's important to have things like the door closed on the back of the IBM. We've had customers that have left the doors open for quick access to sensor pods that are located in the back, and then wondered why their incubator chambers were working so hard to keep their temperature up. And that was because, yeah, it was trying to heat the whole room. Likewise, you need to keep the processing chamber atmosphere and floor set to 37 degrees for good control of temperature in the incubation chamber. These are all designed to work together as a single module. Now, there are differences between the incubation chamber and the processing chamber as far as atmosphere goes. And those differences are in the relative humidity and in the crack HEPA filtration. In that the relative humidity is generally kept higher in the incubators, although you can set it to be the same if you want as the PC. And you only have this crack HEPA filtration in the processing chamber, not in the incubators, which makes sense because that's where most of your particle risk to your cells and tissues are. It's in the processing chamber, not in the incubation chamber where the cells are closed. Now there is a pan that's provided with each incubator, and this looks like the type of pan in a traditional room air CO2 incubator that you would fill with water. But I'm telling you, do not fill this pan with water like you do in that standard incubator. What you want to do is take a little dish and fill that with sterile water and see how long that little dish lasts you. If you need a second dish, add a second dish. Depending upon the conditions in your incubator, that may be all the water you need. You really don't need to fill that whole pan full, and there's lots of good reasons not to, and we'll go through that in a later unit. So let's move on to equipment chambers. These are specialized processing chambers that are made for specific types of equipment, and we can enclose all kinds of equipment. This is a floor standing centrifuge, kind of like this one on the right. It's got an apron that surrounds it, and we can put extra crack HEPA filtration underneath that apron to take particles out underneath where centrifuges like to generate them, as well as above it to control particles. We also do benchtop centrifuges. We do that on a lowered surface so that you have plenty of room to open the lid and get inside there to get your samples out. It's lower compared to the processing chamber height. We also have done centrifuges underneath the floor of a processing chamber like this. So you can put the lid down and you can do some more work while the centrifuge is running. We've even enclosed huge TCAN pipetting robots. This is one that's at Cleveland Clinic. And one thing that this customer told us is that once they got this robot disinfected, the Xvivo system kept it from getting contaminated again. So they thought that was a huge value to their process that they didn't even anticipate when they first set this up for gas control, is that the Xvivo system kept the robot clean. So, and you can have all sorts of different features in your particular Xvivo system, and we'll be talking with you during your learning process one-on-one to assess what your specific needs and questions are for your system. But We've had ideas come from customers for things that could be added to functionalize these spaces better, including things like underfloor stir plates, including things like magnetic plates on the wall for hanging up tools, hanging bars for bags of fluids. And we always welcome new ideas from customers for ways to make the Xvivo system an even better place for both the people in the lab and the cells. So I'm going to stop here and tell you that our team will be expanding on all these basics in the following training units. We make up the application support team that can address your questions about your process here at Biospherics. So don't hesitate to reach out and ask us questions. We're cell geeks and we love to hear about what's going on with you and your process, so let us know. Thanks a lot.